in that, as I said earlier on, as x increases, we see that y tends to decrease. So what we're observing here is a negative trend. It's decreasing. So the fact that it is a negative value within our R value matches up with that. So the R value tells you two important things about the nature of the relationship. The first thing it tells you, and this is based upon the sign of the value, is if it's increasing or it's decreasing. If it's a positive R value, that means it's increasing. If it's a negative R value, that means it's decreasing. So here we've got a negative R value, so that matches up with what we just saw in the data. Therefore, we have data that is decreasing. The second component that the R value gives us is a measure of strength. And it measures the strength based upon like a 0 to 1 or a 0% to 100% relationship, whereby 0% represents no relationship whatsoever, i.e. the two variables have nothing in common, they do not influence each other whatsoever, and 100% or 1, depending upon how you look at it, represents a perfect relationship, which means that if I change y in any way, it is equally represented in x. Or alternatively, if I change x by any amount, it's equally represented in y. So the way that we would see that in terms of relationship would be if we had a straight line and all of the dots were on that straight line. That represents a perfect relationship. Here you can see that if we put a line of best fit in, we're going to get one that's probably going to model the data quite well, but there's no way a straight line can go through all of those points. Henceforth, the strength of the relationship is not 1. So we have a relationship here of 0.76 or 76%. So if we think of it just as a percentage, that's a fairly strong relationship. But what you will find later on, especially with the more comprehensive regression analysis that we're going to do later on, that this isn't actually the greatest relationship in the world. Even though like 76% seems like it's really good, the way that you need to think about these problems is, what if you were going to risk $1 billion on this of your own money? Would you be happy enough with a 76% relationship, or do you think you would want to have a 95, maybe a 97% relationship? Alternatively, what if it was to do with, say, surgical equipment that is going to go out that can be used to cut people open, and if the surgical instrument breaks, it could get stuck inside someone and could kill someone. So you need to think of it in terms of those extremes. I know that seems like very extreme examples, but that's essentially where all of these stats go to. So I've worked in financial analysis, done a lot of work with other economists. Well, I'm not an economist. I've done work with economists in terms of financial modeling, economic modeling, and it's all based around these sort of statistical models. Well, a large proportion of them are. And so it does come down to those situations in which how good do you want it to be in order to risk either people's lives or your own money or some other sort of extreme circumstance, because generally those are the cases that we're representing or we're looking at, especially you can imagine in financial institutions. So overall, what we found is that in terms of the relationship between the two variables, we found that it's a negative relationship, and it's fairly strong. It's an okay-ish relationship. So anyway, I've been going on for long enough. I hope that helped a little bit. I'm going to do a lot of videos in which I'm going to be employing the direct notation that you see within class, and then using that and explaining it each time. So don't be a little bit, put off if you didn't follow 100% what each of these variables meant. But remember, I've been working in maths for far too long, and so this notation to me is actually, I look at this, and to me, this is just a far more beautiful, compact way of representing what we want to say. But I know what it's like to be a first year or whatever in terms of your level of mathematics, and looking at these and just being completely petrified. So I was in the exact same boat. The best thing that I can do is just to recommend. The best thing I can recommend is to just expose yourself and do as much as possible. You'll find over time that it is not done to make your job harder. It's done to make the equations look simpler and easier to understand, which I know is paradoxical when you look at it to start off with. Okay, anyway, I hope that video was informative. If I'm going to be uploading this document, I'll put a link on the YouTube, on this YouTube page, and I'll also put one on the Facebook page as well if you want a copy of the document to look over. So if you have any comments, either post on this YouTube link or post on the Facebook page, or shoot me a message on Facebook or an email, and I'll get back to you as soon as I can. Okay, thank you. Bye.